The next section involves solving absolute value inequalities, very much like solving absolute value equations, but there are a couple extras in here. So I wrote out the steps. They look like solving absolute value equations. You want to isolate the absolute value. This part is the new part. You have to decide if your connector word is and or, because you're going to actually have a compound inequality. Remember, we do a less than sign is and a greater than sign is or. We had that kind of weird little way of thinking about that. We'll split into the inequalities and then solve. But just as before, right after we isolate the absolute value, we do want to check to see if we can think through our answer. So if we have an absolute value of something is less than a negative, absolute value is never negative, so it can't be less than a negative. This would be a no solution. On the other hand, if you have the absolute value of something, whatever that something might be, is greater than a negative, well, an absolute value is always positive, and a positive is always greater than a negative. This actually would be all real numbers. So we have those two special situations we come across that we can think through. So let's go ahead and look at this first one, number 25. First thing we want to do is isolate the absolute value. Well, it's already done. Next, we want to check if there's any special situations. Do we have the absolute value less than a negative or the absolute value greater than a negative? Well, we actually have the absolute value of something's less than a negative, and we know that absolute value can never be less than negative, so this one is no solution. I love those nice easy ones. And that's why I threw the second one in here, so we could actually work one out. So this one, we isolate the absolute value. Well, that's done. It's already isolated. We check to see if an absolute value is compared to a negative. This little red, now blue and red box. Nope. So we can go ahead and solve this. So now we determine and or. Well, this is a greater than sign. Greater than sign. So we're going to use or. And we're going to split up our inequality into as is. 2x plus 7 is greater than or equal to 11. So just this part. But then we do the opposite of what's in the absolute value. Is greater than or equal to 11. And we solve both of these. So we subtract 7. 2x is greater than or equal to 11 minus 7 is 4. Divide both sides by 2, and you get x is greater than or equal to 2. Over here, we distribute. Negative 2x minus 7 is greater than or equal to 11. We would add 7 to both sides. And we get negative 2x is greater than or equal to 18. Divide both sides by negative 2, but we're dividing by negative, so we must switch the direction of the sign. So x is less than negative 9. So we have a 2 on our number line and a negative 9 with a connector word of or. So 2 might be here. Negative 9 somewhere down here. It says x is greater than or equal to 2. It's less than or equal to negative 9. This is in or, so nothing special here. We want anything that's covered, so here's our answer. Let's change it to a different color so it's more visible. So our answer, we put right on our number line. And there you have it. So here it is written out in inequality form, and then we have the graph of it. And so that's solving absolute value inequality.